All right, cool. Thanks everyone. And today we have a little bit a smaller audience. Uh, but again, we'll kick it off. We're sharing the recording on the website, and we're sending email to everyone with the recording. And I know people do rely on these messaging. So let's kick it off. And I'll share my screen. I'll start with a quick deck, and then, as usual, we'll dive into the into a quick demo that we have prepared as well. All right, so today, oops, my apologies. So today we're talking about we're starting to dive into quality assurance world, as you probably notice in some of our articles and some of our we kind of refocusing a little bit on our effort to quality assurance in general. And today we want to talk about root cause analysis. Um, as Steve McGuire said, fix the cause, not the symptom. And we've seen a lot of these cases where people actually trying to address the symptom, or what we many times call failure, instead of actually digging in and trying to find the root cause and solving the problem at the root. And today specifically, we want to focus on one particular part of this whole world, which is root cause analysis, or RCA in short, and how do we propose to manage that with PRIZ and PRIZ platform in particular. All right. So first of all, quality assurance is everybody's job, right? I'm coming from software engineering industry, and it's very popular, or I would say common, where the software engineers they doing something and they basically throwing it out over the fence. And I'm sure every industry out there does, doing very similar things as well, where hey, I done my job, it works on my machine, I think it's tested the best way I can, and so on, and they throwing it over the fence for somebody else to verify, right? That's not the point of quality assurance. And quality is really everyone's responsibility in any organization out there, from at any stage in product development, from the very early design. And Rich, you were the one mentioning somewhere in the posts, uh, um, design for quality, or something similar to that. The quality is integrated from day one, and it's not the afterthought. And we've seen a lot of these, as I mentioned, that the quality assurance folks they added after the fact when failure is starting to happen, which is very interesting. And of course, the quality is a continuous journey. It's something that is not one off, or some sort of stage out there that needs to take place. It's a continuous thing from, again, very, very beginning. And there's a lot of reasons to that. And the bottom line, if you have any interaction in the process at any point in time, you are also responsible in shaping quality. That's period, end of story. But what is quality assurance, right? Let's start with a little definition here, and I dug this out from different sources actually and put it together, something fairly short. But it's a systematic activities that ensure process consistently produce products or services that meet quality requirements, focusing on preventing defects. That's a very important thing. So the right question to ask in quality assurance world is not how do we test for defects. Are we doing the process in the correct way that the defects never happen? Right? That's a very, maybe sometimes people say small difference, but it's a huge mindset shift. So the main goal of quality assurance, I mean, there's a lot of them, but I want to try to focus on these three. Is first of all, of course, prevent defects. The how part, that's the next question, but it is to prevent defects and not to inspect them and find them. right? Uh, of course, insurance ensures consistency, and we all in whether it's manufacturing and software engineer or any other industry, we want to have predictable result of what we produce, either again product or services, and drive improvement. So again, just today in LinkedIn, I saw another small post about quality assurance as well, and like quality is your responsibility, and quality insurance folks, you only responsible on quality and making sure that nothing fails. That's wrong, and we've seen that quality assurance actually can benefit, can contribute much more, and one of them is the continuous improvement processes as well. Now, the values, so if we're talking about the values as well, what does it bring us? If we have a consistent quality, it protects the brand and trust. Of course, the customers are happy. We have a strong reputation in the company, you name it, right? That's not the only thing that will make the customers happy, but that's a big portion of it. We're reducing costs. Of course, if we have less rework, we're throwing away less things, less downtime, and so on. Eventually, we have higher margins and a better bottom line. And excellence culture. Again, we're talking about the continuous improvement and continuous learning, of course, accountability within the team and within the entire organization. And here we want to, even though for some people it will be obvious, but we want to make the paradigm shift in here, and we want to say that quality is basically always at risk. Because if we say that, it's a higher risk or lower risk, then we have a problem. But if we shift our mind, shift our paradigm into saying we have to deal with quality all the time, and we intentionally have to ensure the quality is in place, then and only then we can say that quality is addressed and at the highest standards. Now, of course, we want.
Alex, I just wanted to let you know what you were just talking about is essentially the cost of quality, and I threw a graphic up into the chat just for anybody else and yourself, for that matter, because it's cost of poor quality and cost of good quality, because you're talking about both of those in goals as well as the values, and to help assure the quality, paradigm shift. So have a look at that, and anybody else that might be interested. Anyway, I just thought I'd make it helpful.
Yeah, thanks. Perfect. I'm happy to look at that, and I'll download it to myself after as well. So, of course, we want to compare with a traditional QA, and again, I am coming from a software engineering world, at least in the last 20 years, and I've seen a lot of these inspection-centric. Hey, we're doing something, then QA comes along and trying to find if anything wrong, right? So it relies on the inspections on the final stage, or final stages rather. So for example, if you have a pipeline of production, software engineering has exactly the same thing. There's an interim stages of QA or testing, which is actually falls on QC and not QA. It built on the fact that it detects problems when they occur, and not necessarily trying to look for them or predict them, where the failures will happen. In most cases, from what I've seen at least, we're treating the symptoms or the failures, what we've called, instead of the actual causes or the root causes. So we basically patching a lot of things. It leads to rework, because once we found a failure, there's no way to go back, really. We can rework, we can potentially throw away a lot of stuff, but it just causes to distraction in the organization, and frustration, like written here, and so on. And this is just one of the typical processes in here, typical processes in one of the industries that how quality assurance actually works. And there's a material that comes in, and we inspect that, and if it's something wrong with it, maybe we're sending it back or trying to find something to do with it. when we're producing something again or some stages, we will check it again and go back to rework and so on. So it's that continuous cycle. But the point of that is once the product or portion of the product is ready, it's past the a certain stage, it's too late. If it's faulty, it's faulty. That's it, right? Now you need to spend much more time and money to actually get it back to not back. You can't really fix it, but make sure that your customers eventually not getting that faulty product or service. Now, a more modern QA process, and a lot of companies actually talking about that, is instead of detect and fix, is actually predict and prevent approach, right? So quality assurance begins at the system design. So Rich, again, it's that same thing that you talked about in one of the posts, the design for quality, right? Proactive prevention always outperforms the reactive detention, just from a money perspective, just simply costs less. As simple as that, right? It involves cross-functional collaboration. Of course, it's not only one person's responsibility, like we talked about before. It's everybody in the company. And when I'm saying everybody, it's absolutely everybody. From biggest managers to the simplest engineers. And it has the built-in continuous improvement in its core, which is very important. And continuous improvement, that in my mind, I see that as a continuous learning as well. And one of the pieces, like we talked about, of successful QA, and it's a proactive and systematic, and root cause analysis is a big portion of it. Now, what is a root cause? And we're talking about this in our trainings as well, and this is the approach that we're trying to promote. So root cause in a traditional definition many times refers as a fundamental reason for the occurrence of the problem, right? That's great, but many times it leads to the dead end, right? So for example, a fundamental reason could be a material, a chemistry, it is what it is, or physics works this way. There is nothing much you can do about it, but that is a root cause. Many times it leads to the dead end, or something that happened in the past and you can't really affect it anymore. The more practical definition, and that's what we're usually using, is the root cause as a source of a defect, such as if removed, the defect is decreased or eliminated. And we'll speak about that in just a moment. But the point of it, that even if you have something that happened in the past and you can't really change that, you still can resolve the problem that you're currently having today by addressing a different root cause. And I will send a few articles about that. So we have a small success story here. Anatoly, you want to take this over?
Yeah. So this is example from microchip semiconductor manufacturing. Some wafers fail electrical test. And as QA said, we found very fast root cause. The root cause is a mistake, is a human error. Engineer applied wrong recipe, and thickness of the metal was 20% more than is required. And they said, no problem. We should scrap this wafers. It's a very pity, but we found root cause. We should scrap wafers. We should make additional trainings and so on. So I was completely disagree with this. I said, no, guys, the electrical wafers fail electrical test not because of a mistake, but because our process is not robust enough. And now we have an excellent opportunity to investigate it and understand a real root cause of the of the issue. And we analyzed it. We analyzed it with cause and effect chain. We analyzed it with a functional model with 5 whys, and we found very interesting thing, which is related in another configuration. Alex, you can go to the next slide. So what's happened? We have structure like this. We have dielectric, thin metal, and bump, a copper bump. Copper is a noble metal and doesn't like to sit on the oxide. Therefore, we need glue like metal. And this metal between bumps is removed with plasma, but some residues remains, and this residue is removed by acid. And after removal, the residue, we have a very beautiful structure like this. No undercut. It's typically very, very small, not more than 20 nanometers, 50 nanometers. What's happened in the case of thicker metal? Generally, nothing special. We see the same picture. We see residue after plasma etch, and we place it into acid. And acid removes residue, but also creates very deep, huge undercut. Excellent, excellent situation. It's a good we make mistakes. And we investigated it. By the way, maybe you have some idea. It's very simple. When you use creative thinking tools, you start to think like a creative person, and you understand that the interaction between metal and acid is exothermic, and heat is separated, and you have local heating of this metal. And in case of thin layer, you generate less heat, and in the case of thick metal, you generate much more heat, and interaction goes faster and penetrates inside. And we found that, what does it mean? It means our process is not robust. We're very close to the cliff. Something happened with their temperature, with their concentration, with the thickness, and we failed. And more than that, we found such undercut also on regular on the wafers with regular processing, and we improved it. We reduced concentration, we reduced temperature, and we improved it. This is the difference. So do you have questions? If I explained it clearly, I think it's a good example.
The example here is, again, and I don't think it's only microelectronics industry, it's almost anywhere in the world, where we trying to address, especially in very complex processes like microelectronics, which finding a root cause and we documenting that, and okay, we put the check mark, everything is done, we know why it happened. Now what? And now, many times you see we need to add more trainings for this guy who made a mistake, right? But what it creates only more complex processes. And these more complex processes, it means more complex systems, and more complex systems leads to even more problems and more costs, and so on. We're not actually solving problem, we patching it, and we putting additional restrictions on, and additional processes on, again, adding costs, adding complexity, and there is still going to be human errors. It's not preventable. It will happen. The question is, how do we make sure that if it happens and when it happens, it's not actually killing our product or service, and does that person actually do what needed to be done? And maybe we can simplify, and by doing that, reduce the possibility for the error and also reduce the cost together with it, right? So from one little failure, we can actually find a lot of things that we can improve, and not just doing it for the sake of finding why it happened.
So let's say each error, human error, is a huge opportunity to improve quality, to assure quality. This is if you process by right way, if you really make analysis, if you really search for root cause and understand the process. Okay, Alex.
If there's no other questions, we'll move forward. And I'll unshare the screen, and I will share my other window here, because it's a different app. So everybody sees my screen? I think some people already seen this project. We're using this project a lot for our demos as well as the webinars. A reason for that, because first of all, it's a real life example from the past, and it also has a lot of functionality that we're using inside the platform embedded in it, and it's a really good showcase. And just to recap what was happening here, it's a wet cleaning process that is not cleaning well enough, or wasn't cleaning well enough, and it was leaving defects on a wafer. And of course, here's the project that describes exactly what's happening, with all the details in it, all the background information, what's being tried in the past to solve it. Excuse me. The problem statement was defined also as part of the entire process. But what we want to dive into is the actual creative thinking tools, or problem-solving tools, creative tools, you name it. There's a lot of names to that, that actually essential for root cause analysis, right? And I want to start with a simple
Alex, let me interrupt you. Can you show that AI will show which tools you should start with? If you click,
of course. So normally when it's empty and people don't necessarily know where to start, and that's normal. We have 12 tools today, and more to come. So it's sometimes a little bit difficult to understand which to start with. So one of the AI assistant functionalities that we have embedded in the system, it's actually trying to help people to choose the right tool to use and which one to start with, right? Many times, somebody with a more experience will kind of know it by heart, but many people looking at this entire list and like, okay, where do I start? So this is where do you start, right? And it's absolutely correct. Now, we went with not the process functional model, but the system functional model, which is this one. But it doesn't matter. It actually does a pretty good job, and it explains as well what kind of value you can get for this particular project from particular tools. So this is very helpful, and we've seen it improving and reducing these questions. What's next? Okay. So cause and effect chain, cause and effect chain, like any other tool that we have in a platform, it's structured in a very similar way. We have the subject where we're trying to describe, or we encouraging to describe, that people describe what they're actually trying to analyze with that tool right now. And that's very important to understand, and that's very important for people to understand who work on it, because it focuses them on a particular area of analysis. The then there is the actual analysis themselves, right? So the cause and effect chain, it in our platform, it looks this way. There's a lot of approaches and many people using, for example, Ichikawa diagram, the fishbone diagram, which this is a very similar thing, but looks differently, pretty much, right? But it produces the same result where you digging into the reasons and all the possible reasons of why something might happen, and in this case, defects remain on a wafer, and we're digging into different reasons and digging as much as we need to dig in to understand the problem, to understand the causes, and leave the notes if you need to leave the notes. So this is the thinking tool. Usually something that many times will happen on a whiteboard or on, for example, Miro board. We have it embedded here, and it's under one context of a project, right? When we're building an additional, we're expanding additional nodes, we also have AI assistant here, and it will have the entire context of the the project. It knows about the overview. It knows about the problem statement. Basically, it does want to focus on the problem that you're trying to solve. It knows about this entire chain, right? So it will try to propose different additional possible causes that you may or may not be thinking about, right? So it's like another person on your team to rely on. Now, important thing to mention here: the more detailed we are in the descriptions of these causes and nodes and failures, the better result of the AI as well, right? But if you think about it, the more details we have, even when we're working with human beings, the better result will be as well when you're working with a normal human being. Let's put it this way. So it just follows the same concept. And of course, once we have these analysis, we want to put the conclusions or some sort of outcomes from these analysis in the conclusion section, and I'll show you why is it important as well. Now, one of the concepts that we also writing a lot about is once you have this more holistic view of the cause and effect chain and potential failures, what we want to do after, we want to dive into one of these branches that we think has the biggest potential to finding the root cause, and create and analyze with a different tool called 5 whys, or as we call it, 5+whys, because we never trying to restrict people on a specifically 5 things. And again, if you remember from the little presentation before, it's not the fundamental root cause that we necessarily want to address. Yes, we can for future, and usually the fundamental reason for the problem, if it addressed, it will solve the problem in the future, 100%. But we're talking about right now, and for example, we have, I don't know, 3 lots of wafers that we want to save somehow. So how do we do that, right? So this is typically solving the problem for a future, where these causes, what we call an auxiliary causes, it can solve the problem right now, but not necessarily prevent it for the future, right? And the way we're approaching it, first of all, again, we going with a linear approach now and asking the same question, why something happens, until we get to something called a fundamental root cause, or that is the dead end from our perspective. And then each and every one of these causes may or may not have a solution for it, right? In this case, we said increase the density of chemistry by temperature reduction, right? Why it was part of that decision. Also, this tool provides the ability to rank different possible solutions. and that's using another tool called round-robin ranking or bitwise comparison. Also, it has that name as well. Here as well, we have some help from AI assistant. It's a little bit different than AI assistant. We will probably start giving name different guys in here that working for us. But it also gives triggers our brain a little bit, gets our wheels going in terms of in terms of ideas. The concept of using AI, and always has been, is instead of agreeing with it and trying to just accept what it says, it's the opposite. It's disagreeing with it and argue with it, right? And then, like you arguing with any person in the world, trying to come up with a better solution, Richard, that goes back to your point of constructive confrontation. Same thing with AI, and we trying to create this concept of arguing dialogue versus it is what it is and just accept it, right? So we're working on that piece as well. Now, these couple of tools are great, but sometimes even to come up with a
Alex,
simple structure of, yep.
Just a moment, please, return. Just to show that there is a button learn more, and if you forgot how to operate with, you can get complete information.
Right.
Awesome.
Thank you for adding that. So
I had one question.
Of course.
Can you go back? Yeah. So one of the things that strikes me, if you can go right down to the bottom where you're at, it'll spark me. Oh yeah. So on the constructive confrontation thing, right? As it relates to directly to this kind of thing, you want to have people have ownership of on a team problem solving thing. So that's why you put in all these things, but they're going to come from different disciplines, right? A lot of times, like
of course.
The yield engineer might have one perspective, the process engineer will have another perspective, the chemical engineer will have another perspective, right?
100%.
So that's why you got to do the functional model and do this as well collectively as a team. And that's why the constructive confrontation approach as what I'll call a framework by which to start from with regards to the problem solving activity, that this then sort of enjoins everybody together so that everybody gets heard, right? Gets the inclusion thing going on. And then also likewise, when people have a say on, what the causes are, what you'll find in my experience that I learned was there was a greater level of ownership over the potential solution that you came up with because you did this key piece of involving everybody in the problem solving activity together as a team. Anyway, I wanted to point that out, that's why the constructive confrontation thing is really important for the whole activity. Anyway.
Absolutely. Thank you for that input. And where I was going after these tools is actually the functional modeling. That's the next one I wanted to show. Because what happens, and I've seen it firsthand with one of our potential clients, where people were trying to trying to build, for example, the cause and effect chain, but they didn't even have enough information in their head in terms of how the system functions, which components is in there, and so on and so forth, right? They couldn't even define why the system is in place. It was that interesting, even though they were working with the system for years. And this is where functional modeling, or if you need the process functional modeling, comes into play and be very helpful. Again, in here, we encouraging people to describe what system, that they're going to be analyzing, and then build the functional model. And functional model, this is just one of the example of this of this system. Functional model, of course, helps us to understand how the system functions, and it helps us to model the failure many times that we experiencing right now. We had comments from a few customers as well, where, hey, we just need to build the functional model once for our existing system because system is rarely changing, and when it changes, we'll update it. But no, the thing is that you're building a functional model per case, and that's very important. It forces us to learn the system, relearn the system, how it works, what kind of interactions in there, what components involved, what product is the system built for, and so on. And of course, the platform calculates a lot of pieces like the functional rank and problematic rank. And what we introduced in here is operational effectiveness and operational perfectness. Now, why is that important, right? These two parameters, they basically speak about the complexity and the cost of the entire system, or in case of process functional modeling, about the cost and the complexity of the process, right? Now, the power of these tools, and I'll go over these in a moment. The power of this tool as well is when we decide to change something in the system, in a typical way, we either create some sort of prototype, and in software engineering, it's very popular, where you do something very quick, very dirty, because in software it's very cheap. It's normal. You do the prototype, you see if it works, conceptually, and then you kind of move forward. So again, in software, it kind of works because it's cheap. In manufacturing, it's much more it's much more expensive to do, or these kind of prototypes. But what functional model allows us to do, it allows us, since we already modeled our system and our failure, it allows us to simulate the change going forward, right? So for example, we know the components and we know about the change that we're trying to introduce in the future, so we can model the system after that change. And of course, right after, we can see a completely different picture. For example, operational effectiveness goes up, great. The perfectness also goes a little bit up, maybe not enough, and we define it anything above 2 is kind of green. Again, it doesn't mean that you need to stop there. There is also always room for improvement, but it's the relative number is something to look at under 2. Now, I want to talk about the simplification and the continuous improvement piece of things, and let's look at the first example here. As I mentioned, we calculating the functional and problematic rank, and as you can see, some components, they have both. They have the they contributing to the value of the product, but they also contributing to the problem. And some of them only contributing to the problem. So they don't have really any value, but they're there. So why do we have them? Again, going back to continuous improvement, these components are the ones to look at when we want to reduce costs, or trying to simplify the system, or trying to streamline the processes. This is where we need to look at and focus in trying to address our problem or improve the system. And it doesn't need to happen only when an incident happens or some failure happens. This kind of analysis can and should be ongoing thing all the time. And in my mind, if we're talking about QA and talking about the root cause analysis, it's not only failures, but even when you're trying to improve the process, that also requires root cause analysis. Why is it not, what's the root of the process not being optimal, or not being, or why is it so expensive, and so on. There's so many questions to ask and dig for an answer. And of course, again, conclusions can come out of it many times. Another small thing that I wanted to show, there's a few cases where we are proposing recommendations for the next steps. Each and every one of them will have a little bit different recommendation, and sometimes linked to another tools, like for the inventive principles, and so on. So and we developing that system further. Now, One last thing that I wanted to show, and I want to leave some time for questions, or as we usually do for discussions, is a report. If you remember, I mentioned people do it for the check mark and just close the incident for the management. And the one thing that they actually working for during this entire process is to produce a report or fill up some form and say, okay, this issue is done, I done my job. But the actual product of root cause analysis process, in this case, we're talking about root cause analysis, it's not the report. It's actually solving the problem, solving the root cause, right? So we're trying to make sure that the report is not the focus of your activity, right? And that's why the report is basically generated for you. And that report includes the entire everything inside this project, from the very beginning of definition and the background to the definition of the problem statement, to also winning ideas, because as we're working through the process, we're generating ideas for solutions or potentially even the reasons for the the causes, and so everything is documented inside the platform, and of course the proposed solution, right? That's the preventative actions or potentially even corrective actions. So in this case, short-term solution, I treat that as a corrective action, and then long-term solution, that's a preventative action, right? It depends on the industry, it has a little bit different names to that. And of course, every tool and everything that we do inside the platform, including meetings that getting documented inside the platform as well, they all visible in this report as one big report, and there is nothing that a person that works on it needs to do about it. He needs to just
I have a question, Alex, about this. Well, one of the things that I used as a best practice when I was at Intel, and I've used it since training others, which is that have everybody always do a report out to management to show the validity and value add of using such a method like PRIZ, whereas the report generates everything that you did that you can then throw into a presentation, say 2-3 slides, but then also have it as backup for when you're presenting to management if they ask any questions. So, oh, this is how I figured it out, kind of thing. But also, something that you and I have talked about prior, which is, having an ROI, also becomes, for a project. So this becomes the all of the cataloging of information that you would need in order to provide it to finance, or if you're just doing your own ROI analysis, with an Excel spreadsheet, right? This all provides collateral for. So I think this is great. I mean, this is a handy way to.
There is another benefit to that, especially when you're talking about continuous improvement or decision making or continuous learning or rather, and what happens usually, let's take Intel as an example, right? How problems being solved and managed. Emails. After a week, I'm not talking about years, after a week, you have no idea where the information sits and who owns it and where is that. You have a gigantic thread in the email that has something in it, right? With 1 million people in it. This will allow you to look back into why was decision made, how was your thought process when you got to that decision, and so on. A year from now, 5 years from now, 100 years from now, it doesn't matter, right? And I see that as one of the biggest benefits in this quality world. Jens?
Yeah, I also have a question. Yeah, first of all, Alex and Anatoly, thank you very much. It was a very enlightening presentation. And I like the thought very much that you say, okay, in a classic cause and effect chain analysis, we get to the root cause, but that could be, we could end up at some law of nature, and then we know it, but there's nothing we can do about it. And what I was wondering is if we look at the not the 5 times y, but the cause and effect chain of your wafer example, what would you suggest in this diagram? How could we best identify a cause to work on to find a solution to prevent the problem from happening? So at what level would you suggest working on, or how to identify that specific cause to work on?
Right. So it's a good question, and I don't think there is one answer to it, really, because you don't know what you don't know. But what you do know, you know the current state of the system, right? And it's a given that if the system too complex, you will have more problems and more human errors and so on, and more costs, right? So even cause and effect chain can help you in identifying these things, even as simple as asking, why is it so expensive? Or why do we need all of these crazy processes in place that restrict us and guardrail us, right? Even at that level, even without having an actual incident in place, you can use these tools to kind of trying to look forward. But the point that we were trying to make in here, that incidents, really, it's not an incident. It's an opportunity for us, right? It's an opportunity for digging in deeper and understand and learn and create that culture of learning and culture of quality, right? And as Richard mentioned as well, it's not the QA people that needs to do it. They need to drive it potentially, but they're not the ones who, they're not the only ones who purely responsible for it. It's the entire organization, whoever needs to be involved, right? Does that answer the question?
May I add a few words?
Of course.
This is creative thinking tool. Like chess. When you play, you think. In the end, you stop thinking, and it becomes not so interesting. The process is the most important. And when you build it, you think and you generate ideas. So therefore, we have this very, very good button, and we can keep ideas, save ideas in the idea manager. Alex can show you idea manager. No, it's okay. Yeah,
it is
sure.
Idea Manager. Yeah. Idea
Manager, and we have special system for ranking of these ideas.
And also this is the additional tool that we have for collaboration and bring in additional information about each and every one of the ideas that potentially can come from team members and different teams, different what's it called, disciplines as well, right? Even when looking and analyzing a particular idea. Sorry, for interruption.
Yeah. We also have meetings, like you can schedule a meeting. You can send task. Gents, please bring beer, and you will get email due date and everything. And again, nothing special in this except one thing. Everything will be kept within the project. You should not need it to look for in your Outlook which email, which meeting belongs to which project. Everything is integrated in one file. And you cannot manage a report. It is frozen. You have to get into the system and change something in the inside of the tools, and a report will be automatically updated. And what's value of this report? It's this is copyright of idea. This is fingerprint of idea. If you came and say, apple fall down on my head and I got an idea, it's not sometimes not good enough. Here you can show that you started with a problem definition, you analyze it, you used relevant tools, and you logically came to the solution. This is yours. If someone said, oh no, I have this solution, please bring explanation. How did you get to this idea? So this is
another thing that I personally seen in my work, that it helps to bring the same language between to shorten the gap between management understanding and engineering understanding, because they many times talking different terms, different languages, different interests, you name it. There's so many problems that coming out of it just because they don't understand each other, right? And we've seen it. I'm sure everybody in this room.
Yeah, I totally agree with you. I like to use function analysis a lot for that purpose, because even in the same company you have sometimes so many different perceptions of how a system actually works that you should start to bring people on the same page before starting to troubleshoot or to do anything else innovation related.
Absolutely.
Something I want to add that I think is really cool that you've put in here that I don't think I ever saw before, which was the tasks, which would be action items, you know, in my terminology, having come from Intel. But that, I think, is another thing that can be, again, cut and paste out of the report. I'm assuming it shows up there, right? Can you go back to it, by the way? Because I was really liking looking at it, because I was like, oh, hold on a second. Does it have deliverables on it? Or I don't know if it was in the report or if it was in the...
you have an access to this report, right?
Yeah, but I was wanting to show it to everybody else to point it out. It wasn't a matter of I have access to it. It wasn't a matter of that. But it was a matter of sort of illustrating this was something that could be from the task point of, because you were doing it in the, not so much in the report out, but in the on the screen, right? That was a part of one of those things that you were tracking. That was that actually helped the whole problem solving process, because this type of activity would be extended over a period of time. So then thus in turn, you'd want to be able to track action items or tasks that other people needed to do before you could come back and actually finish stuff. I don't know where that was at. Oh, there it is. Yeah. Okay.
So this is kind of
on
the
the
dashboard.
Yeah. Okay.
Again, we rarely dealing with a single problem. We dealing many times with multiple different projects and different problems. And this thing that's your task, your personal task that you're involved in, and your personal meetings that you're involved in, showing up here, right? And then some overview of the projects that you're part of and the ideas that exist in these projects as well. So we try to put it in like one holistic view of like your day-to-day, and hopefully that helps people.
I have to go to another meeting. Alex, you and I are going to meet, say 10 minutes from now, because both of us probably need a break. Yeah. So I'll meet you in 10 in the meeting. Hey, everybody, thank you very much. Alex and Anatoly, great presentation.
Thank
Spot
you.
on. I think it's exceptional. Well done. All right, guys, got to go. We'll talk to you later.